Oh, but that's my, no, that, we're going to kind of put it together, hopefully. Okay? So, today we're going to do 2-4, which our heading, let's see what our heading is, solving polynomial equations, which this comes from factoring, quadratic formula, factor by grouping, a little zeros in there every now and then. You know what I mean?
Yeah.
Okay. You could also solve by using your calculator, but at the same time, guys, if that calculator ever gets taken away, you want to know if you still have the skills, correct? Okay. You can, but I also am a big proponent of work. So if all of a sudden out of nowhere you get the zeros because you looked at the graph, you know what I mean? I'm not going to be too happy. Can you check? Sure. Okay, make sure you're doing something. Maybe you're doing one that I'm going to show you today or tomorrow, I can't remember, or next after the test, I can't remember. Anyway, one of these times, there's one time that does take you a while, and if you want to go ahead and find a zero, awesome. Find that. Okay, here we go. So today, 2-4, we are going to solve some polynomials. Does everybody remember the good old quadratic? That's always important. Okay, if you don't, here we go. Okay, I sing every now and then, and here's what it is. X equals negative 2 plus or minus square root of b squared minus 4ac all over 2a. One more time. Let's sing it right now. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. You can't be embarrassed. My teacher, when I taught this, she came in a weasel costume. I'm not joking. Great time. All right, when do we use the quadratic formula? It tells you. Okay, we use it on quadratic equations, right? Make sense? Okay. So sometimes you're going to have to solve, maybe it doesn't factor. Now, if you also, once again, you said maybe you struggle factoring, this works every time on a quadratic. Okay? As long as it's quadratic. Right? Such as this. X squared minus 2x plus 4. That guy doesn't factor. Factors a 4 that add to be negative 2. There is negative. Right? Does that make sense? Okay, so what do? We got my A, we got my B, we got my C. Okay, now I know Miss Merkley, if you went to her class, once again there was Miss Beathers, Miss Merkley, and Miss Spangler, correct? How many of you guys have Merk? Just curious. How many of you guys had Beathers? Awesome. How many of you guys had Miss Spangler? Okay. I'm calling why they're still all with her. Anyway, A equals 1, B equals negative 2, and C equals 4. With that being said, okay, Miss Merkley always liked to show you guys, I bet, the discriminant. Which the discriminant, if you don't know, is this guy right there. She asked you to find that without you putting it under the square root, correct? There's some value to that, but we're freaking in honors. Take your trash and take your name. Okay, here we go. X equals negative b, or opposite b, plus or minus square root of b squared. What's negative 2 squared? 4. Notice I keep singing my song. Minus 4 times 1 times 4 all over 2a, which is 2. And then we just do some order of operations. Please follow your order of operations, where it says 4 times 1 times 4 is 16. 4 minus 16 is negative 12. So, we like this. What does anybody remember what this is called? True. What is this called? Imaginary, right? Imaginary number. Why? Because they're imaginary?
Yeah, why? Why?
Huh? Because they're still there.
But they're imaginary,
So,
not.
I'll stick you in the shoe. again, I prefer you to simplify this, okay? Notice this is 2 plus or minus 2i root 3. Hopefully you guys may remember that just because you're smart kids. Remember, square root of 12, just to give you a heads up, 2 times 6, 2 times 3. To get out of jail, I don't do that, but isn't that, remember, square root of a negative number is I, right? And then what does this guy all have in common? 2. So because they all have 2's, this is 1 plus or minus I root 3. Those are your zeros. Those are the solving, right? Everybody there with me? Those are all 2's. So that's just solving one. By the way, I'm going to put this equal to zero. It's in the complex plane. It's in the you guys learned how to graph in the complex. I haven't graphed in it. No? I swear that was part of your guys' core that.
What's an example?
I haven't graphed in the complex plane for many years. I think this is your real, and this is your complex one, right? So therefore I'd go over 1, up root 3, which is roughly right there. It's been a long time for myself, so. There you go. You guys remember doing this, though? Notice how many zeros are there? 2. 1 plus I root 3, 1 minus I root 3. How many zeros should there have been? Because it was an x squared. Remember how we discussed that yesterday? Doesn't matter if they're real or imaginary, right? They all have to add up to be the degree. So sometimes if it's degree 4, okay, it's degree 4, how many do I need to have? 4. So guess what? Let me put this in your notes. Complex numbers always come in pairs. Conjugate pairs, to be honest. Like, for example, if I told you 1i, or just I is a 0, guess what else is? Negative I, plus or minus, conjugate pair. If I told you 1 plus I root 3 is, what else 0 do we know? 1 minus I root 3. They always come in conjugate pairs. So once again, if I had 4, I could have 2 imaginary and 2 real, right? So if you only saw your graph, even though it was like that x to the 4th, right, and it crossed like this, basically, you only crossed twice, didn't you? Correct? You have 2 more other zeros that are complex, don't you? Does that make sense? Everybody with me on that? You will get 4 zeros, okay? But 2 of them might not be real, okay? And because of that, these guys come down. Will I ever have 3 on x to the 4th? Will I ever have 3 real numbers and 1 complex? Because why? Complex always come in conjugate pairs. So if you have 1, you know you have another. Does that make sense? Yes, no? Okay. All right. Fairly okay? We all right? Okay. You've already kind of did this one. This one kind of looks nasty, but just brush it off and say, I can do this. Okay, like 4x cubed minus, I'll make this up, so we're going as we go. 6. Sure, 6x squared. Minus, no, definitely not. No. Oh, whoa, hold thou horses. We'll do it 12. X, and then a lovely plus 18. Bam, right there. How many of you guys have ever factored something with an x cubed before, except for like the one we did up here when we pulled out a common factor? Is anything in there common? No. Well, oh, shizzy. We could do that. Pull out the 2.
But you still got an x cubed.
Okay, do these have anybody that I can just pull out except for just the 2? I can't many of you guys have ever, well, I want true. How many of you guys have ever factored something like this? Tried it yesterday. You don't believe me? You did. Okay? Ready? This is why I show factoring a specific way as well. What do these guys have in common? X squared. What's left over? Awesome. What do these guys have in common? But because he starts out negative, I'm going to plot a negative here. Does this look like something yesterday? This is called factor by grouping. We group the first two, we group the back two. Huh? Right there with me? Very important. You're going to see quite a bit of these. And then we factor out the, yes sir. Yep. I'll have two right there. And then notice what's left over? X squared minus 3. Bum, bum, bum. This thing? That's a 3. Where did you ever see a C up in here? Let me help you. There you go. Oh my hell. Picky. I like you anyway there, James. Get used to it, people. This is only the 4th day. The X squared is still here. Okay, let's find our zeros. You guys ready to find our zeros? Because that's what we were asking, is maybe to find the zeros, right? Okay. So what value makes this guy 0? Oh, there's no value out here, so we don't even care about him. Go away, really. Okay, he's not important. Really, he's not. He just makes us skinnier. What value makes this guy 0? 3 over 2, good. Everybody good there? What's our multiplicity on that fella? 1. 1. Okay. 1. You understand why it's 1? Okay, I thought you said 2. Go ahead, Jake. Tell what multiplicity is. That's the power of 1, right? You should just say mult of 1. Okay, what's the value that makes this guy 0? Well, let's set him equal to 0. That's a 3. We add the 3. Square root it. Oh, shush. That's my answer, right? No! Thank you, Tyler. It is a plus or minus. I'm calling you Tyler. Not Josh. You have straighter teeth. Just teasing. I wish I had. Those are pretty. Your parents spent $5,000 on them. I'll shut up. Okay, what's the multiplicity on these guys? They're still 1. Sorry. Better? Just let me know anytime. Okay. Notice these each have a multiplicity of 1 as well, because what did I start with? X cubed, right? Correct? Here's 1. Positive 1, negative 1. There's our 3 zeros. Okay.
So is it usually just when it's a square root that it becomes a plus?
No, well, that's exactly. Anytime you take an even root, okay, there's a plus or minus, because technically, once again, why is there a plus or minus? Because I could have went, how do I know what number did I plug in here to get 3? Did I do negative square root of 3 squared to get to 3? Or did I do positive square root of 3? Does that make sense where it comes from? So on odds, obviously there's only one way to get there, right? What is the cube root of negative 8? There's only one, negative 2. But square root of 4, 2, that's 2. But what I did here, I am putting a value in for that. So what value could I put in for that? 2 or negative 2. So anytime you take an even root, that is the plus or minus. Good? Okay. questions so far? I'm going to do no shave till Christmas. I'm going to start that in November. Dude, I love it. That's just wrong. It's summertime. How would I factor him? No. It's not a factor, not solver. Factor. Go ahead, Stephen. No, sir. No, sir. I see what you're saying there. I see what you're saying. But, once again, these guys are not timesing. They're subtracting, right? If I was able to do this, I'd go xy raised to the fourth. I could do that, but that's not, that's not what I, no! Stephen, no! This is called the difference of squares. We discussed them last time. Remember, aren't they both something squared? Right? And what do difference of squares factor into b? Conjugate pairs. So what is the square root of x to the fourth? X squared. What's the square root of y to the fourth? And then, once again, and then remember, negative and a positive. Those are conjugate pairs. Am I fully Tanner Wood? I don't know, but the board looks weird. She's lovely. Okay. Am I completely simplified? Factor. Did I factor this guy? No. That's a sum of squares. You cannot factor a sum of squares. Well, you can, but they're imaginary. Can I factor him? What's this guy? Another difference of squares. That would be completely factored. Maybe. I don't know. So now, though, I could go ahead and factor, if I ever needed, to x to the fourth minus 16, can't I? Right? Because isn't those both something to the fourth power? So this would be x squared minus 4, x squared plus 4. Can I factor this guy? No. Can I factor this guy? Yep. Yep, this is a difference of squares. Oops. That's all the way over there. Make sense? Notice now I can find my zeros. Do you want me to scroll up? Sorry. I can find my zeros really quickly. What's my zeros? 2, negative 2. You can do plus or minus. What is the square root of 4? Plus or minus 2i. So this would be x squared equals negative 4, right? So I take the square root, that'd be plus or minus 2i. Right? And notice how many zeros did I get? And how many should I have? Makes sense? You guys getting it? Clicking? Where did my paper go? You were ready for that one, were you? Front row. You guys are so excited. Ooh, I love those ones. I like that one. Yep. Yep. I'm so tired. Oh! Oh! What's this guy called?
microphone on the right of the search bar right there?
What?
Look,
I think you're...
I'll show you this.
Well, do it right there.
Right there?
Tyler, say difference of...
Difference of cubes.
Hold on.
Okay, Google.
Jay, do it!
Difference of cubes. Okay. Difference of cubes.
Okay, we're pausing. Here's difference of cubes. There you go. Copy that over there. We'll wait for people to write down real quick. Okay, so therefore this is pretty easy. Then I can find my zeros doing what? Because obviously, I can't just set him equal to 0. Because once again, that would only give me what? One of my zeros, right? What? X cubed minus 27 equals 0. X cubed equals 27, right? Take the cube root. X would be 3. This guy. But, where's my other 0? I need 2 more, don't I? That comes from here. What would I do? Quadratic formula, wouldn't I? Because I couldn't factor him, correct? Does that make sense to everyone? No problem. Okay, you understand? I just added him over, took the cube. You're okay with x equals 3. Well, remember, how many zeros should I have because of my degree? 3. This is not a multiplicity either. This is a multiplicity of 3. This is a 3 with a multiplicity of 3. So I got to find my other 2, and my other 2 come from this guy, and doing quadratic formula, which would you guys want me to hear him count through really quick? Count it. X equals negative b, which was 3, right? Plus or minus square root of negative 3 squared. 9 minus 4 times 1 times 9. Right? All over 2a, which is 2. So, negative 3 plus or minus square root, that's 9 minus 36, which is negative 27. Correct? All over 2. Trying to help Nicole in the back. Okay? This is going to be negative 3 plus or minus 3i root 3 over 2. Those are your other zeros. So what are your zeros? 3, comma, that stuff. There's your 3. Does everybody see it? We got 1. Our second one is negative 3 plus 3i root 3 over 2. Our third one is negative 3 minus 3i root 2. Yes, no? Feeling comfy somewhat? Just you somewhat. Okay? Study. Grades good. Good. So 1, negative 1i, negative I, okay? Once again, did it have conjugate zeros or conjugate pairs for our zeros with the imaginary? It should have, right? I and negative I, those are conjugate pairs. Okay, so here's what this guy is. X minus 1, X plus 1, everybody there? Yes, no? X minus I, X plus I. Notice these are conjugate pairs. So when I FOIL them, don't they become difference of squares? Right? Does this become x squared minus 1? What does this guy become? X squared minus I squared, but what is I squared? 1. Not 1, negative 1. So negative negative becomes a positive, so now I'm at x squared minus 1, x squared plus 1. Those are conjugate pairs. Right? So what does that go to be? fourth. Sir?
So you're
That was last year, but I can hurry and count through it since we have time. Okay. Square root of negative 1 is really easy. Square root of negative 1 is I. So therefore, if I square that, so therefore I squared is negative 1. And then I cubed is, notice that's equivalent to I times I squared. What's I squared? Negative 1 times I, negative I. And then I to the fourth is I squared, so that's negative 1 times negative 1, which is 1. Okay. All right, guys, that's